As an electronics, IoT, robotics, and embedded systems engineer, there is one thing we always have at the back of our mind, and that is what we call the pin configurations whenever we are designing a firmware. So a firmware is a software that runs on the controller, microcontroller, to control the physical components or devices on the actual electronic device. So for a controller to control other devices connected to it, it must know where they are connected, which pins they are connected to the microcontroller. Is it an output or input pin? And what does that component do? How does it communicate? So all those are defined in the firmware to allow the microcontroller, the chip, to control them correctly, and also to receive information to communicate efficiently with the components. For example, those components that use serial communications, like the Bluetooth module and all those, there are those that use PWM communication, there are those that use analog communications, and there are those that uses digital communication. So whenever you are defining these pins, you must indicate whether they are inputs or output, how they communicate, and where they are connected to the controller, the number of pins. So the microcontrollers have also the different, they are segregated as power pins, serial communication pins, digital pins, analog pins, and yes, they work differently. So you cannot connect an analog device to a digital pin. It will not work properly. So and there are some other pins that are safe whenever they are not connected. They can, if you connect a device, it can also either interfere with the functionality of that microcontroller or end up damaging the controller, strapping the microcontroller. So this you must have at the back of your hand whenever you are writing the codes. Those are the first things you do whenever you are creating the firmware. Firmware is different from operating system, is different from application system. I've said firmwares run on the low level on a microcontroller. They are also software that deal directly with the hardware. Then we have operating systems that run on a firmware. They collaborate with the firmware to control the physical device. Then we have the application softwares that run on operating system. Without an operating system, you cannot install or use an application software on these gadgets. And the application softwares, they serve the end user. You interact with them directly. They can communicate with the operating system, which manages the resources and manages tasks within the device. It manages the application, the tasks, the resources that are available, then communicates with the firmware. Then firmware does the controlling of the physical devices, and that is the difference.